Hi, I'm Dave Hobbs for Team AVI, and welcome to this program on how to ace your ASE A4 steering and suspension test. Now, steering and suspension systems have remained much the same for decades in some aspects, but in other aspects, radically different. So we're going to see a lot of variety in this program. We're going to cover things, mundane things, such as tire pressure, but also high-tech things, tire pressure monitoring systems and diagnostic equipment to work on them. We'll talk about the basic fundamentals of steering systems and things like this tie rod end and a stabilizer bar bushing. We'll progress up through the changes of steering systems and get into variable effort power steering systems and the steering angle sensors that go in the columns. We'll talk about struts and springs and all those essentials for making the car ride smooth, but also include electronic ride control. So this will hopefully help you make more money in the shop tomorrow and get you on the road to passing your ASE A4 test so you can wear that patch on your shoulder with pride. So let's go ahead and get your student guides ready and a sharp pencil and begin this program. Let's get started with our first topic, steering systems, diagnosis, and repair. Now, the repair part, the diagnosis part, make sure you're comfortable in your ASE A4 study guide with the task list. The ASE task list covers all the kind of things that possibly you've done all these things, but maybe there's a few of these items you've never done, repaired, adjusted, diagnosed, whatever, but at least make sure you've read up on them in your study guide, and we'll also help you as we do some hands-on demonstrations along the way in this program. Now let's get started with 4 areas that we can have problems with steering systems, breaking them down into poor handling, hard steering, fluid leaks, and noises. Let's talk about hard steering to get started here. We have a question already on hard steering for a manual steering. That's a car without power steering. In a vehicle with manual steering, a complaint of hard steering can be caused by all the following except. I want to make a special note here. You see the word except is in bold. Anytime you see the word except or not, anything in the negative, make sure you make a big mental note of that when you take an ASE test because it can trip you up every time. They're basically looking for the wrong answer as opposed to the normal correct answer. Let's look at the list of possible answers and we'll pick the wrong one out. We're looking for the cause of hard steering on a manual steering system. So not power steering equipped, which of these would not be causing hard steering? Low tire pressure, worn steering gear components, incorrect wheel alignment, or damaged steering system components. Let's look at a symptom chart and see if this is covered. Hard steering for a manual steer. And sure enough, here's our manual steering diagnosis symptom chart. The second one down here, we see hard steering is listed, and we have 4 items that can cause hard steering, one of them being low tire pressure. And that was on the list of possible answers to that first question. Insufficient steering, suspension, and lubrication. Well, first off, back to low tire pressure, that makes sense. A tire that's low on air is going to be harder to turn, get less fuel economy, and also harder to turn left to right as well. So insufficient steering, suspension, lubrication, anything that's dry. So the suspension, the steering linkages and so forth on a manual steering system, if they're dry, it makes sense, it's going to be hard to turn. That word makes sense. That is something we need to keep in mind when we do any ASE tests. Not everything is in a fog of high-tech mumbo-jumbo with black smoke and modules. There are a lot of things. In fact, the majority of car repair is a common sense approach to the fundamentals of mechanical things. So if we think about stiff suspension, or stiff steering I should say, we have a possible cause of being dry, lacking lubrication. So that makes sense. Damaged steering system components, that's damaged. So if, like, let's say a center link or a tie rod were to be bent, maybe you hit a curb or something like that with the vehicle, it would be damaged and it'd be harder to turn the wheels. And also incorrect wheel alignment. If the wheels are fighting each other going down the road with the improper toe, that could also cause hard steering. And if the steering gear itself is just too light, causing hard steering. So we go back to that question and we see one of those answers that's wrong. That's the only one to select because we're looking for the except in bold here. Low tire pressure we talked about, that can cause hard steering. Worn steering gear components, I didn't see that on the little symptom chart. So let's talk about worn steering gear components. If a steering gear component is worn, that means it's loose, and that means maybe the steering characteristics going to feel loose. It's going to maybe wander, or you're going to give an input to the steering wheel, and it's going to be delayed in how much the car moves to the left or right as you turn the wheel. But certainly it's not going to cause hard steering, the difficult to turn steering wheel. So the correct answer to this question, the wrong answer, they're looking for the word except there, would be B, because we know we've talked about incorrect wheel alignment and damaged steering wheel components and low tire pressure could all be causes of hard steering. The one that can't cause hard steering, or usually won't, would be worn steering gear components. Let's go on to our next question. Here's a question about a vehicle pulling to the left or right as you're trying to steer straight down a level road. Vehicle pulls to the one side during straight ahead driving. The cause could be A, loose steering shaft joints, B, misadjusted manual steering gear, C, wheel imbalance, or D, unequal tire inflation. Well, let's look at that symptom chart again. So here's our list of symptoms, and on this part I don't see veering to the left or right, or pulling as you might call it, but here I do. We see the second one down on this particular slide. Car pulls to one side, and 3 possible causes. Unequal tire inflation. That makes a lot of sense. If you've got a tire, let's say it's 15 psi, almost going flat on the right front, and a tire with 35 psi on the left front, guess which way? It's going to pull. It's going to pull in the direction of that low tire. So you want to put down unequal tire inflation. Other things can cause pulling to the right or left: incorrect wheel alignment. We've got toe in or toe out on one tire. Loose or worn suspension components. If the vehicle is kind of listing, like it's got a broken spring or something like that, it's going to want to pull towards that side. Also, a defective tire, a tire with a belt that is separated, can sometimes pull to one side or the other. But definitely unequal tire inflation, one of the most basic things to do before you ever put the car in the rack and start, on the lift, start inspecting tie rods and things. Just get out the tire pressure gauge, see what the pressures are in all 4 tires. If you live in California, that's the law. You got to do that on every car you work on for whatever reason. You work on it and document it. So in the rest of the 49 states, the rest of us need to get in the habit of checking tire pressure religiously. Not all cars have TPMS. All cars since the fall of 2007 have had TPMS. We're still working on a lot of cars that never had that option. So definitely the answer is unequal tire inflation. Our next question: to remove a steering wheel from the staff, from the steering shaft and the steering column, use A, pry bar, B, hammer, I'm liking it so far, right? C, puller, or D, screwdriver. Well, let's go to the car and actually take a steering wheel off a modern vehicle and see what it does take, the proper way to do it in your shop, and the proper way to answer the test question for ASE A4. Well, one of the first things we have to do, we work on steering columns, whether we're just fixing the tilt wheel or removing the column and replacing the column, is we have to make the airbags safe. So most vehicles since the late 80s into the 90s, standard equipment airbags may have numerous airbags on the vehicle: side curtains, side airbags in the seat or the B-pillars, and of course the driver steering column mounted and frontal passenger airbags. So how do you make them safe? Well, manufacturers vary somewhat from vehicle to vehicle. Some will have you pull fuses, but a surefire way, and some manufacturers actually come out and say, just take the battery cable. So take the negative battery cable off and wait a minute, which we've done. Now, what that minute wait is, airbag modules contain capacitors that store power in the event of a battery failure. So if the battery is smashed in the frontal collision and there's no power then to deploy the airbag, it's like model rocketry. A little bit of power and ground, even from a 9-volt transistor radio battery, as I already mentioned, is going to make the chemicals in this airbag begin to burn and rapidly within a few milliseconds, we've got this huge pillow in front of our face, which while it will deflate immediately, which is part of the absorption that an airbag does, absorption of energy, kinetic energy, but the force of it coming forward, if you were to be working on it, have a tool in its way, and for some reason it were to go off, now that may seem to be a little overkill, but let's think about it. Why is the vehicle in the shop? It's got a problem. Could it have multiple problems? Sure. Could somebody have been monkeying around with something? Or could some wires be chafed in the steering column? You may have some 12-volt hot all the time power, and certainly there's ground because there's metal in the column. If those two wires were to, and it would be a very rare instant, but if they were to happen, short together while the airbag was powered up, then it could deploy the airbag right at an inopportune time, which could result in injury or even death to you, the technician. So powering the airbag down, taking that battery cable off, waiting that minute, that allows those capacitors that are there for reserve energy for the collision in case the battery's damaged to discharge, to bleed down, and then with no power on the vehicle anywhere, and those capacitors bled out, we can disconnect the airbag at the column. So that's what we're going to do next. We've waited, we take the battery cable off already, so we're going to do by feel here. We're going to pull off a little covers for the airbag screws, and then we'll get busy taking that airbag out and talk about steering wheel removal. There we go. Now, get my little 10 millimeter, 8 millimeter. Help my power tool. Go. Capture that screw. Keep an eye on your hardware. Never turn the hardware loose, like I almost did when working on steering column. Lots of small intricate parts, especially with tilt mechanisms. Now with the hardware removed, the airbag come out. Some of them are actually held in with some clips, or it takes a couple of pocket screwdrivers and the right amount of knack, and they come in, and I'm sure there's a J tool for everything, but sometimes we just don't have that kind of assortment of tools or that kind of money, so we got to use what we got to use. But this one's held on with hardware with some screws, so I'm going to disconnect the horn circuit here, get a little extra, and you may be able to see the airbag harness right here coming out of that clock spring coil. That coil of wire, it reels up and unreels like a fishing reel, or more like a trouble light actually, as it comes out of this little recoil mechanism hanging in the ceiling of your shop. So now with a little bit of loose wire, we can see those connectors. And it's important, it should be polarized, meaning you can't get it backwards. But look anyways, and they may not have it polarized. This is a two-stage airbag. Now, since we have disconnected the battery and waited a minute, even if there were shorted wires down lower in the harness getting ready to give power and ground into here, there is no power because the battery is disconnected, and that airbag module itself has the electronic module, its capacitors have drained. But getting these back in the right place is going to be really important. This is a two-stage. Both stages are deployed for a bigger airbag under a larger collision, a more rapid deceleration, a more severe collision, and just one stage if it's a lesser severe collision. So I'm going to go ahead and depress these and pull them out, and we see this is black, this insert, and what color is it right here? It's black as well. So make sure you get that right when you go do airbag removal after you've done the depowering of an airbag. There we go. So now the airbag assembly is removed. Do not set it like this on the table, because if it were to have gone off somehow, it's going to shoot up and whatever is on top is going to be damaged, and it could be you. So lay it with this is called the egress side up, and it'll be a safe method of laying it down. I'm gonna lie it right over here on the floor. Now we got the steering column. Now we got to figure out how to get the steering wheel off. And on this particular Ford, we've got one big bolt with a Torx fitting. That's going to be removed, and then we're going to get the puller out and pull the wheel. Now it's important to read the manual. The manual is going to tell you this is a bolt that is to be discarded. So it's a torque to yield type of bolt where you use it once, torque it, and when you remove it, you throw it away and get a new one. So that's a little bit about steering columns. They vary vastly in their construction. Pivot pins that can go bad, springs, and all sorts of mechanisms. They're a bit like a Timex watch as far as taking them apart, but they can be taken apart, they can be serviced. Bushings, bearings, pivot pins, little kits for rebuilding them. Typically when they get loose, they start, slopping around here, jiggling around, and that's when it's time to go in there and start working and servicing on that column. Sometimes you can do it in the car, other times remove the whole column from the car, put it on the bench on the vise. But either way, they're going to have airbags in all cars today. Deactivate that airbag electrically and then unplug it and remove it like I just demonstrated. That may be a question you'll see on an A4 test also. All right, let's talk about power steering now. Power steering's been around for many years, and we're starting to do some things with it, like replace it with electric power steering. But this is hydraulic power steering you're seeing in the figure, but this is a speed sensor in this particular picture. We're going to talk about that kind of a system where we vary the effort for power steering. We can make it a little bit tougher to turn the wheel or a little easier to turn the wheel based on vehicle speed and maybe even steering shaft or steering angle inputs as well. But basically they all have a pump. The pump may have a remote mounted reservoir, or it may have the reservoir built onto it, whether it be a rack and pinion type of steering system like I'm showing in this illustration, or the old recirculating worm gear or steering gearbox. Both can use power steering. Now, because we're going to be pumping high pressure hydraulic fluid, we have a pressure line as well as a return line back into the system. Important you can establish which is which, because you're going to be putting a power steering pressure gauge when you diagnose the system. We're going to talk about that because there's test questions coming up regarding power steering pressure and testing. Here's some power steering pumps you may run into, and how they look on the inside really is not of any kind of matter on diagnosing them, whether they're roller or vane or the slipper style. This is basically a hydraulic pump. As the engine starts and a belt turns the pump, it's going to make pressure. The faster the engine turns, the higher the pressure it makes. At lower speeds, you may hear a squealing noise. We're going to talk about belts in this program because belts are important for mechanical hydraulic power steering. Now, as we migrate to electric power steering or electronic hydraulic power steering, belt goes away. But in most cars, we've got the belt. If you hear a noise of a belt slipping, the squealing noise, when you first start an engine and you don't give any input to the steering wheel, that's going to be the alternator loading that serpentine belt, or maybe it's an older car with separate belts for separate accessory drive units like alternator, water pump, and so forth. But if you hear a squealing noise of a belt slipping, that's the alternator working very hard as it tries to recharge the car's battery. On the other hand, if you only hear the squealing of a slipping belt, when you turn the steering wheel or turn it almost to lock position, that's extra pressure from the pump binding up, causing the pressure to go up and the amount of work it takes to turn that pulley to go up. And if you have a loose belt or a glazed belt, a defective belt, needs changed or adjusted, that's when you hear the squealing noise. So most techs know this. Maybe you're one that's not worked on this particular type of area of the car before. Maybe you've been a transmission tech and you're moving into chassis and steering and so forth, or you just want to get master certified. It may not be that obvious, but that's been a long time problem. As you turn the wheel and you hear the squealing, it's a power steering belt that's loose. Pumps can be, like I mentioned before, remote and not have a reservoir built onto them. They can be aluminum body, and they can be a cast iron body. So it varies from vehicle to vehicle and from vintage to vintage. Here's some things we have to know about when we go looking at power steering fluid. To check and fill. And obviously, to check power steering fluid, it's much like checking automatic transmission fluid. You need to have the engine, aka the power steering fluid, warmed up between 120 and 180 degrees Fahrenheit. So it's got to be warmed up. Got to go for a road test. You got to be on a level surface. And unlike the automatic transmission, you don't check it while the engine's running. You ever taken the power steering fluid reservoir off of the pump or the reservoir if it's remote and did this number while the engine's running, you know it's just splattering all over the place. So the engine's got to be off, but it does have to be warmed up. When you look at the fluid, just don't check the level. Now, most vehicles have a graduated, like a dipstick on the end of the cap, but not all. If you don't have a graduated dipstick on the end of the cap, simply take a flashlight and look down in the pump with the engine off, warm engine, but engine shut off. It should be, the reservoir should be about 2/3 full. Or just measure it. Wipe it off like a regular dipstick, put it back in, pull it out, and see where it is. Make sure you use the proper, I started to say transmission fluid. Many power steering systems may use transmission fluid, but check to see what that manufacturer calls for their power steering fluid. This one says use approved fluid. Okay, we know that. Fill to proper level, do not overfill. It does not tell you what kind of fluid. So you want to check it out either in the owner's manual or in the service manual and see what kind of fluid this particular pump and reservoir would need. Now, as you look and inspect the fluid, get a white paper towel, tissue, something white, wipe it off, and look at the color of the fluid and also the viscosity. If it's brown and thick, maybe it even smells like varnish, like old paint that's went bad, oxidation has taken place. It also may smell burnt as well. Oxidation means it's burnt up, so it's been overheated, and that's going to have to be flushed and refilled, and possibly you've got damage that will still be there. You notice, a whine or something like that out of the pump. Next, also look to see if you've got any black particles. If there's black particles, that's the insides of the hoses. Hoses for power steering systems, they handle a lot of pressure on the pressure side. Now the other side is more of a suction return back into the reservoir and then in the pump. But on the pressure side, they usually die from the inside out. And then if you see metal particles, you can take your magnet on the end of your screwdriver, see if anything comes up with it. If you've got metal particles, you've got steering mechanism damage or possibly the pump itself. Now, AirSep, the people who make primarily air conditioning tools and accessories for, very niche type of repairs, they're making a filter that has a magnet on the inside of it. And according to one remanufacturer of steering racks, their warranty rates have went way down significantly because this inline filter has been installed in the power steering hoses and is collecting the debris that normally would wreck a steering gearbox. So you might look into that if you're having repeat comebacks for power steering problems at your shop. Look into AirSept, A-I-R-S-E-P-T on the web. Find out where you can find these magnetic filters. There's really a neat little idea. Now also, if the fluid looks milky, you may have air in the system. So then you have to look at where's the air getting into the system, tighten up hoses, find leaks, and so forth. Now, let's go down to the hoses. They die from the inside out, and they should not be hard or spongy. And always, 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 when you go to crack a line loose from the pressure side of the pump, there we go, we'll point right there, that side will be a compression type fitting. Want to use a line wrench, so one of those wrenches that goes around almost completely, and not an open end wrench because you're just Murphy's Law. These are pretty tight on here to seal an O-ring that needs to be replaced, by the way. When you pull that line off, you want to inspect it, make sure the O-ring's not damaged or missing because you'll have a leak there. Maybe suck air in if it's on the inside, or the output definitely lose some power steering fluid. Check those O-rings, but use a line wrench to break that loose, because if you don't, you're liable to round it off, and now you're stuck with this rounded off fitting on a line, and now you're in big trouble. So replace both the hoses when you replace a power steering hose, so not just a pressure or the return, replace them both, because if you've got that murky black stuff from the hose dying from the inside out on one, it's going to be in the other. And then flush if the contamination is present anywhere. So you want to take the line loose out of the pump, the return line, and you want to just fill the system as the engine runs, and you turn the steering wheel from lock to lock, but don't hang out, don't prolong the lock where you're seeing a lot of you're hearing the pump groaning and laboring as you've got it locked to lock. Just do it for a second and then back off of it and keep turning the wheel. And as one tech does that, the other tech keeps pouring the fluid in until it starts becoming clear again. Basically letting it leak out as you pour it in and work the system from side to side. That's a typical flush. You have to have the engine running, by the way, and elevate the front end, because that'll help prevent air getting in the system. Well, here's a question about servicing a power steering system that you might run into on the A4 test. And it reads like this: when removing a power-assisted steering gear, so that'd be the recirculating ball screw type of a steering gearbox, do one of the following. So we're looking for the correct answer here. A, clean the steering gear and hydraulic hoses. B, disconnect the return hose from the reservoir. C, pull the fluid out of the system with an evacuator. Or D, save the old fluid and reuse it if in good condition. Now, let's just use some common sense, as we need to do first step with any ASE test question. And if you're going to be removing a power-assisted steering gear, let's say you're going to replace it, why in the world would you want to reuse that old fluid? Top it off with some fresh fluid, flush the system completely with fresh fluid, something like that. So I think we can almost be safe to scratch out D. Now C, that might make sense, pull the fluid out of the system with an evacuator, but why would we do that unless we had contamination, we had a pump that's basically destroyed itself, something to that aspect. B, disconnect the return hose from the reservoir. Or A, clean the steering gear and hydraulic hoses. Let's examine those questions a little closer as we look at this illustration of a typical steering gearbox with power steering. Now, here we have our recirculating ball screw, or the worm drive steering gearbox, a conventional system. And there's your pressure line and the return line from the power steering pump. And of course, we're going to have the pitman arm, or sector shaft, as it's sometimes called. You're going to have to remove that to remove the whole unit, and just unbolt it from the typically mounted to the frame rail of the vehicle. But then you've got the power steering hoses to deal with. Now, one of the answers, possible answers to this question was, should you remove the power steering hose, the return line, from the reservoir? Well, I'd say no, because that's just going to get in the way. If you've got a line you remove from the reservoir, that means implies you're going to leave it on the steering gearbox, and now you've got this big line flopping around in your way. So I would think you would want to remove both lines from the gearbox and simply have the gearbox with no hoses sticking out of it. So that would make sense. The other question, possible answer, was clean the gearbox and the fittings around it. And that makes sense, because you don't want to get contaminants. There's typically a lot of grease and dirt and things hanging out around this gearbox. Why in the world would you want that getting into the power steering hoses? Possibly when you put the new one on, or if you rebuild it or do something to that gearbox, put it back on the vehicle. Now any of those contaminants could have got into that return hose and literally sucked back into the power steering pump, possibly damaging the pump. So clean this all up with some brake clean or degreaser or something like that. Blow it off with shop air, and now you've got clean fittings. It's the same as in a fuel system, and then take things apart. Makes life a lot easier and avoids the comeback. So the correct answer to this question would be A, clean the steering gear and hydraulic hoses. Another question about power steering systems. When bleeding the power steering system, A, elevate the rear axle so the fluid flows better. B, the fluid should be cold during the procedure. C, turn the steering wheel lock to lock and hold for 30 seconds. Or D, watch the reservoir and top it off as it gets low. Well, part of the bleeding of the system is you're going to have the engine running, all right? So if you have the engine running, it's not going to be cold. So we can eliminate B as a possible correct answer. And then turning the wheel lock to lock and holding for 30 seconds. We talked about that earlier. That's where you get the high pressure buildup, Not really the best thing to do for a power steering system, especially when you're bleeding. That means that you've got one line taken loose and you're literally pouring fluid in as fast as you can pump it out. And you want to make sure that reservoir stays full. So when you turn it lock to lock, if you were to run out, that'd be a bad situation for the pump and the rest of the system. So I think we can eliminate B and C from our possible answers. Raising the rear axle so the fluid flows better is actually the opposite. If you want to get the system filled better, you want to raise the front end up. So A, eliminated, and the correct answer, of course, to this is you want to watch the reservoir as you run the engine, and you turn the wheels back and forth, but no, hold it for 30 seconds at lock to lock, but watch the reservoir and top it off as it gets low as you bleed that system and flush it out with fresh fluid. So the correct answer to this question is D. Watch the reservoir, top it off as it gets low. This next A4 question you might get into concerns using a pressure gauge in the power steering system. It reads like this. To pressure test a power steering system, install the pressure gauge between the A, return hose and reservoir inlet, B, sump outlet and suction hose, C, pump outlet and pressure hose, or D, steering gear outlet and return hose. Well, it almost seems to be every one of those answers except for C, Charlie, has to do with the low pressure side. So think of a power steering system like you would any other pressurized system, such as a fuel system, or better yet, an air conditioning system where you have a high side and a low side. In this case, we have a pump, just like an AC compressor, and it's going to pump high pressure in a certain direction, and then it's going to do its thing, and whatever the load is, in this case, it's the power steering gear or the rack and pinion gear, or that system leaks and it's not going to have a pressure drop or differential. So let's look at the system with a gauge hooked up and see if my hunch is right. B sounds like where I'd want to put a pressure gauge to at least to check the high pressure side of a power steering system. So as we look at this illustration, we have the power steering pump where life begins for pressure. And since this is where the fluid comes into the pump, this must be like a suction line or a low pressure side. So we're going to make pressure with that power steering fluid, with the pump, and we're going to send it normally without the gauge installed right into the steering gearbox or the rack and pinion system. If you want to install a pressure gauge, you install it on the high pressure side, which would be the pump outlet and high pressure hose. So there's a high pressure hose. It would normally plug into the back of the pump. We're going to put this gauge in series between the outlet of the pump and the high pressure hose going into, in this particular application, the steering gearbox. So there's where you put the gauge. Now, if you've never used this gauge, you don't have one at your shop, you've not experienced with this, please read this study guide to get more information about how to do it. It's not that hard, but it does take a little knack. You're going to have to open this valve right here, the shutoff valve, all the way, and that's going to give you what's called system pressure. And as you record system pressure, then several times, if you don't have enough system pressure, you're going to close the shutoff valve and see if the pressure comes up any, and that's going to make a difference in diagnostics. And if it doesn't come within the right number of PSI, when it's open versus closed, then you go particular directions. That's basically how it's done. But to answer the question, where do you put that gauge? The question's correct answer is C, between the pump outlet and the pressure hose, or the high pressure side of the system. Next question might come up, and here's where you might look at a chart and see what symptoms are, what pressures are, and see what makes most sense. Comparing the readings from a pump pressure test. A pump test says, how much can the pump put out if I close this? So I'm going to open and close it several times, see how much the pump can put out. And if it puts out, let's say, within 50 PSI of what system pressure was, that's a good thing. But if it's more than 50 PSI, less than 50, and so forth, then you want to look at this chart. So we're going to put the chart up here next, and there's a chart with the illustration of where you put the gauge. Power steering system test is around 1,500 PSI on most cars. Check specification in the real world when you go out there in the shop working on these power steering systems. But that's a good ballpark, rule of thumb. But if it's more than 80 PSI, there's another issue. Oh, by the way, there's also a test called the gear / rack pressure test, where you turn the steering wheel lock to lock. Don't hold it, like I mentioned before, but just a second or two, turn it back the other way, and see what the pressures are as you move the wheels fully. That's called the rack or the gear pressure test. Let's go back to that question again. Comparing the readings from a pump pressure test, you find that their range is 80 psi. So it tells me that the pressure control valve in the back of the pump can't bring that pressure back down. It's letting it spike up a little too high when there's a restriction. By the way, if you have the valve all the way open and the pressure is higher than specifications, you don't say, wow, that's a great pump, I like that. You say, that pump is trying to pump against a restriction in the system. But when you make the restriction by screwing that valve in and that pressure goes above 80 psi, additional 80 psi over what it was, let's say it was 1500, now it goes to 1600. In this case, 1680 is what this question is saying. It's going on, or 1580. Then you go, the pump has no ability to throttle itself, if you will. The control valve is bad. So the correct answer to this question is A, repair or replace the pump flow control valve, or just replace the pump. It's got the valve built into it. Well, it's time to get our hands dirty. Let's go to a typical vehicle with a power steering system. We'll talk about pulleys and pumps and belts and tensioners, steering linkages, and even variable assist power steering. Well, let's do some hands-on demonstrations on this 2004 Lincoln Town Car to drive home some points to help you understand steering, diagnosis, and repair for your A4 test. Now, a question that may come up has to do with something as simple as a drive belt. It reads like this: to adjust a new power steering belt, moderate thumb pressure at the midpoint of the longest length between two pulleys should deflect the belt about 0 to 0.25, or about 1/4 of an inch, 0.25 to 0.5, about 1/4 to 1/2 an inch, 0.5 to 0.75, or about 1/2 to 3/4 of an inch, or 0.75 to 1 inch, so 3/4 to 1 inch. How much should a belt deflect? Well, most V belts have died the way of the classic car, but the multi-V serpentine belts are here to stay. In fact, they're evolving very much as well. And as we look at the proper tool in this illustration, a belt tension gauge, if you've updated your toolbox for one for the multi-V serpentine belt, it's not a problem. But if you're going off of the old deflection, we need to know a little bit about how to do that. So let's take a look on the car with using a simple tape measure to see how much this belt really deflects. So what I'm going to do is I'm going to find the longest point, longest stretch. That'd be between the alternator here and the power steering pulley itself. So that's a pretty long stretch. Let's go ahead and do the bending right there. So what I'll do is I'll put a tape measure right in front of the camera over here, and I will move the belt up and down. So I'm able to get about 1/2 of an inch, 1/2 to 3/4 of an inch, and the same thing going downward. If I start at about 2 inches here, I can go down about 1/2 or more. Now, you may think, well, I could push it further than that. Certainly you could. Look how far you could push it, but also look what's going on with the tensioner. So deflect the belt to the point right prior to the tensioner to start moving, and then make that measurement, and that's a tight enough belt. Now, they're not adjustable. Most vehicles with the serpentine belt have a tensioner, but the tensioner is something that requires service and replacement periodically. If they get noisy, if they start wobbling, if the surface of the tensioner is not smooth, all those things you want to look at when you diagnose problems with power steering, because power steering is dependent on a good tensioner to keep it going. The correct answer is C, about 1/2 to 3/4, or 0.50 to 0.75 inches just prior to moving the tensioner. If you can get somewhere in between there, the belt is the right tension. Also, what you want to make sure, and you may have questions come up like this, to make sure that the belt, the pulley itself is straight, so as you rotate the pulley, maybe take the belt off or at least run the engine and eyeball all the pulleys on all belt-driven accessories, not just the power steering pump, because it's in line with all the rest of them. But make sure you have no wobble, don't have a damaged face of the pulley or something like that. And of course, looking for the belt quality. Is there too many cracks in it? Is it glazed? All the usual things that we look at drive belts prior to making a decision whether we need to replace them or not. Let's go on to our next question. This has to do with the power steering pump as well. And it says, when removing the power steering pump, do all the following except, so we're looking for the wrong answer once again, run the engine with a hose disconnected to drain the system. Cover or plug the hose ends to prevent system contamination. C, remove the belt drive, the pump drive belt before removing the pump. Or D, support the pump while removing the mounts. Okay, so now we're looking for a wrong answer here. Now, obviously, taking the belt off, that's common sense. Remember, much of ASE testing is just good old-fashioned mechanical common sense along with some up-to-date training. So definitely support the pump or removing the bolts, because you don't want the thing falling. You don't want it also falling with the hoses, attached to it, damaging the hose or just damaging the pump if it falls on the ground. Also, the belt has to come off. That's Mr. Obvious there. So C and D, those answers are correct. We're looking for that incorrect. The word says except in that question. If we look at A, run the engine with a hose disconnected to drain the system. Well, we do have to drain the system, but I'm not sure about running the engine. And B, cover or plug the hose ends to prevent system contamination. And here's a power steering pump. If I've got hoses for the pressure side and the suction side, the return side on the vehicle, it would make sense to go ahead and plug those up so I wouldn't get contamination. So really, we've eliminated 3 of those answers as being possible wrong answers. That leaves only A, run the engine with a hose disconnected to drain the system. Now, that may be part of a flush procedure, but you're filling the system when you're doing the flush procedure as a hose is off and you run the engine. You certainly don't want to take these hoses off here, even one of them, and then run the engine with this unit not being refilled, because what you'll have is a system running empty, and that is going to damage the pump. While we're on the subject of pump damage, lots of things can damage the pump. Contamination, of course, air in the system, not enough fluid. There's a pump. We see there's our pressure hose, and there is our suction hose, and we would want to cover the hoses up, plug them up when we remove the pump. Obviously, remove the belt, support the unit. Next question. In a vehicle with a power steering system, a buzzing noise heard at all times when the engine is running. The most likely culprit is A, low pump output, B, air in the hydraulic system, C, an internal steering gear linkage, or D, normal relief valve operation. Well, that's a very annoying symptom that a lot of customers really pick up on. The frequency of it is within most people's hearing ranges, and it just drives you crazy. The buzzing noise, what is it caused by? Well, it can be caused by vibration from the engine, specifically the power steering system. It has its vibrations of its own, grounding out against something. So a hose, or the pump itself, or the reservoir. There may even be a TSB, Technical Service Bulletin, addressing that vibration. So make sure you look and inspect all the lines and the hoses, even the cooler, the reservoir, and make sure we don't have something loose or something that's been bent and kind of vibrating against a piece of the body, inner fender well, firewall, whatever. If all that looks good, then we want to look at the possibility of air in the hydraulic system. And that is the answer here. Now, getting air out of the system, there's procedures to do that, and they vary from manufacturer to manufacturer, but typically one of them is you take the cap off, and if the system's full, in fact, we can go ahead and check the level of this Lincoln Town Car right now. I can see if I put my flashlight in and then kind of rock the car up and down, you can see the level moving up and down. There it is right there where it says minimum. Now, it should be checked on a warm engine. So we're on a cold engine right now, so being at minimum on a cold engine would be fine. When this warms up, it'll be up to the full mark. If you have air in the system, oftentimes it'll look foamy or even kind of white, like milk, milkish looking. So what you want to do in that case is you want to follow the manufacturer's procedure, which on some cars may involve a plunger plug that fits tightly into the power steering reservoir opening, the filler neck, and it puts the system with a hand pump under a vacuum. And you run the engine and you move the steering wheel from lock to lock, and again, not lingering at full lock more than a second or two. You do that about 10 times. Then you shut the engine off. Then you take the vacuum away. Make sure you top the fluid off. Repeat that procedure. And that should get the air out of the system. Well, hydraulic power steering has been around for years, and there'll be basic questions on the A4, but there's also going to be questions about something more in detail of high-tech power steering systems, and that would be the variable effort power steering systems. Here we have a General Motors EVO, electronic variable orifice, and as we get a close-up of the solenoid right here, this solenoid is going to be turned off and on as a duty cycle, pulse width modulated duty cycle, and that's going to control the pressure output from the pump. So if the pump has a varying amount of pressure, your power steering assist has a varying amount of assist. So when you're in a situation of a parking lot, low vehicle speeds, that's one of the inputs to the module. On General Motors trucks, that module actually may be packaged into something entirely unrelated to power steering, such as their pass lock module, the vehicle theft deterrent system module. But it happens to be there, but we have VSS, and we have power, and we have ground, and we have the output to the solenoid, and the faster you go, the less power steering help or assist that you need. So the solenoid duty cycle changes to give you that varying assist. Then you slow down, vehicle speed is detected to be slower, and the module changes that duty cycle signal to the power steering. So it's still hydraulic power steering, mechanical power steering, but it's using a solenoid to change the amount of pressure you're getting. On other vehicles, and General Motors is the other example I'll use, they don't vary the pressure through a solenoid on the pump. They put a coil, a magnetic coil, on the pinion gear, around the pinion gear of the rack and pinion systems. And so now we can assist the turning with a permanent core and a field around that core. We can assist the turning along with hydraulic power steering. So these systems still have power steering that's hydraulic, but we assist it or resist it depending on the field that is set up around that pinion gear unit on the rack and pinion system. Those are called MSVA, magnetic steering variable assist. They work on the same principle as the EVO, electronic variable orifice. They simply look for vehicle speed, and as the vehicle speed goes down, we assist. We allow more power steering assist for the parking lot maneuvers where you need it, but as the vehicle speeds up, we take that assistance away. In the case of MSVA, it actually resists you turning the steering column a little bit to give you that feel of the road of a non-power steering equipped car, which we always liked, until we got the parking lot to make a parking maneuver, that is. Then we wish we had power steering. So it gives you the best of both worlds. Now we're going to lift this Ford up, and we're going to take a look at its power steering system. It has also a variable assist power steering system. We'll see how it works. We'll also talk about other things that have to do with the steering itself, the tie rods and the rack and pinion, all the stuff underneath the car, questions that may come up on the ASE A4 revolving around steering. We're underneath this Lincoln Town Car, and we're going to talk about the steering linkage, questions you may see coming up on the ASE A4. Now, on the screen you have an illustration right now of a parallelogram on the top. Now, that's used with the traditional ball screw steering gearbox. This is a rack and pinion vehicle, even though it's a frame vehicle, longitudinal, conventional transmission and differential in the back, but we still use the rack and pinion systems on a lot of modern full-size cars that are rear drive and even some light-duty trucks. So it doesn't use the idler arm and the pitman arm with the center link in the middle and a couple tie rods ends. It uses a couple of tie rod ends coming out of the rack and pinion system. So what you look for, and you may see questions about this, is internal rack leaks sometimes will actually leak externally, and if you don't have a good fitting around the boot to the tie rod end, you may see oil or signs of oil. Always check the boot itself for signs of cracking or splits, and also grab the tie rod end and move it up and down. That's going to be a test question, though. That's not really a scientific way of determining if it's loose enough to replace or not, but at least it gives you a ballpark whether to get the tool out, we're going to describe next, and do some measurements on it. Now, as I'm looking and inspecting this particular rack and pinion on this Lincoln, I see a connector right here that goes to the Variable Assist Power Steering System, VAPS, that Ford calls it. And that's the kind of system that has a solenoid that is pulse width modulated to control the flow of high pressure power steering fluid into the rack to get you a little stiffer steering when you're moving down the road at speed when you don't really need power steering, and then give you a very well power assisted steering for effortless parking at slow speeds when you say you're parking in a parking lot, something of that nature. So VSS is an input to that sensor. If that sensor were to go bad, we could have issues, or not the sensor, you probably have a code for that. It's the sensor probably used for the engine control system. But if the system itself had a problem, the module or the solenoid was open or shorted or whatever, you would have symptoms for power steering assist, whether it be open or closed, would depend whether it's going to be stiff steering or wandering steering at highway speeds. We want to inspect the entire steering and chassis system, by the way, for anything loose. We're looking for bushings. We're looking for stabilizer bars that connect two independent suspension members, the left front and the right front, together. And if the stabilizer bar, and here it is, a big stabilizer bar up front here, if the bushings are visibly cracked or deteriorated, or the bolts, the little rods that connect that stabilizer bar to the steering knuckle, sometimes they physically break and they can be replaced, or the bushings there go bad, you can buy new ones. So you may see questions about, what would a symptom be if we had a thumping noise when I turned a corner or whatever, and could it be a stabilizer bar bushing or stabilizer bar mount? And of course, most certainly it could be. Now, we do have a problem with this car, and I discovered it with I shouldn't say it's maybe the correct tool, but it's a tool I've used forever, and that's this big old piece of wood. Now, you can use a big long pry bar. I'm sure there is a J tool out there to do this job. I've never purchased it, but what am I doing with a huge 2x4? Well, in the manual that you've got, your student study guide, it talks about the axial play on the ball joints. Now, radial play, we've discussed, is moving back and forth like that. Well, axial play is where you put a long pry bar or even a 2x4 between the ground. So we're coming from the outside like this. The vehicle's maybe 4 or 5 inches off the ground, and then we're loading that tire, pulling up on it with this big lever, the 2x4. And there's supposed to only be 0.06 inches of play. But guess what? That's almost nothing. So if you feel a bunch of slop, it is typically a load-bearing ball joint. Question reads, when checking tie rod articulation, that's how loose the tie rod is, A, elevate the rear wheels, B, disconnect the inner tie rod ends, C, use a pull scale, or D, disconnect the steering shaft. Well, the correct answer is using the pull scale. So there is an actual specification of how loose that can be. Now I'm wiggling on this left tie rod, and I'm going to wiggle on the right one, and the right one has a little bit of play but almost none. There's a spec, so make sure you answer the question correctly. It's not just wiggling, it's using this pull scale, the spring scale. Also, while you're under the vehicle, make sure you check power steering lines that may shoot off to a power steering cooler. It looks like this vehicle may have one. And just general inspection. Just use your eyes. Use every sense that the good Lord gave you. You can hit suspension components with a big mallet, a soft mallet of some kind. Just give it enough of a rap and see if you can hear a vibration. Oftentimes the customer will complain about a noise. You need to go out and drive the vehicle. Make figure eights. accelerate, decelerate, do all the kind of things that a customer might do, and listen to see if the sound is a grinding sound or a rattling sound or a thumping sound. Is it vehicle speed related and so forth. Then do a good visual inspection, including grabbing things and pulling up and down, using a spring scale if you've got one, to see if you have anything that's loose in the way of the steering. And we also discussed a little bit about what's coming up in the next segment, Chapter 2, on suspension systems, a little bit about front suspensions. Rear suspensions the same way. Inspect, inspect, inspect. Bushings, mounts, the components themselves, any kind of the stress in the metal and so forth. Oftentimes things are just common sense. They're broke and they got to be fixed. So anyways, that'll conclude what we're doing underneath this car up front. Well, you may see a question on your A4 that's on a very new system called electric power steering. Now don't confuse that with variable assist power steering, which has electric solenoids or coils or something to that effect to help you get the best of both worlds, a stiffer steering at high speeds and a much easier to turn steering wheel at low speeds, like in parking maneuvers. This is totally electric. In other words, there is no hydraulics whatsoever. Now there is a variation between the two. There's electro-hydraulic power steering. Honda dealt with that for a few years with some of their smaller cars, I believe the Civic, where you had an electric pump that was controlled by a module, and that electric pump pumped up the power steering pressure much like a mechanical pump, belt-driven pump would. But this system on the Chevy Cruze, and dates back into some of the vehicles like Chevy Malibus back to as early as 2005, has totally electric power steering. And here's how the question might read on your test. A vehicle with electric power steering has just had a replacement rack installed. Technician A says that an alignment should be performed to ensure proper tow. Technician B says the steering angle sensor should be reset or relearned. Who is correct? Well, before we go any further trying to answer this question, let's dissect it a little bit and use good old common sense. It's going to help you out so much on ASE test. Whether it's a 70-something car or a 2011 Chevy Cruze like we're working on right here, don't matter if it's got a mechanical, manual rack, power steering rack, variable assisted, or total electric power steering type of a steering rack. If you replace the steering rack, the rack and pinion, you're disconnecting the tie rods from the steering knuckles. And you have to do an alignment for tow when you put the vehicle back together. So Technician A is right off the bat. We don't have to know anything at all about electric power steering. Technician B, however, is adding something to the fracas. So we could have an A only or answer C. So we've already divided this question into a 50-50 chance. But let's talk about Technician B. He's referring to something called a steering angle sensor. A little device like this that goes typically in the steering column, so the steering shaft and the column goes through it like that. And as you turn the steering wheel, this sensor, either optical or in some cases a couple of potentiometers and a little switch that opens and closes, tells a module not only where the steering wheel is pointed, but also how fast it's being turned, and in some cases the torque you're putting on the steering wheel as you turn the wheel. That's very important to know. The module wants to know, am I just doing nice little lazy maneuvers, just little corrections, I'm driving down the highway, or am I doing one of these numbers in the parking lot as I'm trying to park the car? Obviously the latter, I want more pressure, or I want more electric help if it's electric power steering. And if I'm just doing these numbers, then I want a stiffer steering. I want a less electric help or less hydraulic fluid if it's hydraulic variable assist power steering. So these have been around a while, and they're also used on cars with stability control. If the car starts to slide sideways and you're seeing a yaw sensor start to see the car spin around, or a lateral accelerometer checking sideways movement of the car, that combined with what you're doing with the steering wheel, am I making small inputs or am I doing it on purpose, that also helps an ABS/stability control module know what in the world is going on with the steering angle request. So this sensor serves several duties. Now, when you want to put in a new part, whether it be a module for the electric power steering, the electric power steering motor, the rack and pinion, this is going to have to be relearned. Let's look a little bit in how power steering on the electric version work? And we'll come back and answer this question for certain now. This next illustration, you see the three kinds of electric power steering systems. Now, a couple of them I'm familiar with, being an old GM guy. Chevy Malibu, the very first one on your left, that's one that's got the little electric motor that helps assist the turning of the steering shaft and the steering column. So it's inside the car, and this is a very similar setup right here off of a little import car, so it's not very large, doesn't have to do a lot of work, but it's electric power steering. And then we have same thing, but move the electric motor to the middle, called a pinion assist, right down there at the bottom of the intermediate shaft, right on the pinion gear. And then finally, like this Chevy Cruze has, we have an electric motor. We'll show you here and shortly. Electric motor, huge electric motor, 12 volts on the actual rack. Now it's interesting that on the hybrid Tahoes and Escalades, what GM calls their two-mode hybrids that they've had for about the last 3 model years, those use a 42 volt power steering system because you have high voltage of 300 or more volts in the hybrid system. They say, hey, we'll just drop it down to 14 to charge the battery through our converter, DC to DC converter, and we'll drop it also down to 42 so we can have a little extra edge of steering that vehicle with a little bit more muscle electrically. So whether you've got electric power steering in any of these places or not, you put on a steering rack. That's Mr. Obvious. That's a basic mechanical common sense question. We know technician A is right. Technician B says, do I need to do a reset or relearn on the steering angle sensor? And no matter what, if you're replacing that sensor, sometimes disconnecting a battery on some cars, like Chrysler for example, you may have to cycle the key and do some kind of a feature. It's pretty simple to relearn that sensor, that steering angle sensor, or you may have to use this factory scan tool. So they kind of vary all over the place. Make sure you know there are variations. ASE A4 won't ask you which particular model does what, but it may ask you some of those variations. So the answer is both technicians are right. You got to do a tow with an alignment job with a rack replacement, and probably should relearn this when you deal with any kind of a steering component on the vehicle. While we got this vehicle here in the shop, let's go ahead and get it hooked up to our GM MDI, the Tech 2 replacement for vehicles of this nature called the Global A architecture that have 3 speeds of CAN data. No longer will work with the Tech 2. They work with its successor, the little MDI PC computer. Now we're going to take a look at that and look at some PIDs and see what we can do with electric power steering in the bay. So we get a little bonus here, learn more about how to pass your ASE A4, and also work on a new system you may see in your shop before you know it. Okay, I've got the MDI hooked up, and if we can get the key on, don't start it yet, we're just going to do a key on. There's a list of modules, and they are many, let me tell you. We start with engine control module at the top and go down through fuel pump control module. And let's see if I can get this scroll to work there. All through the radio itself, passenger airbag module, telematics, remote heater, air conditioner module, airbag module, you name it. This car has got modules on that CAN bus, and we're going to take a look at the power steering module. So it's already highlighted. I'm going to go ahead and say enter, and we got a key on, engine stopped. We'll check codes first off. They have the ability to do self-diagnostics with electric power steering. That would be a must. You can imagine if you have regular hydraulic steering, and we talked about this in the program, if you don't get that spool valve, that centering valve in the rack or in the steering gearbox just right, you can start the engine, and as that pumps up power steering, it can move the steering wheel all by itself. Well, imagine what we can do with electronics if something goes wrong. So we definitely want to make sure we're monitoring the system, you're checking codes when you have it in your shop, and you're doing things like resetting the steering angle sensor and doing the right procedures, because you could put somebody in a harm if you don't get that electric steering right for that vehicle. We're going to go ahead and hit enter and see if there's any codes. And we have no codes, so that's good news. And it keeps updating this particular scanner to tell us if we're having codes as we progress. So I'm going to go ahead and go back up. So we have code monitoring capabilities with this particular module and this scanner. Let's go ahead and go into data display and look at PIDs. And we have a handful of PIDs here. We've got battery voltage, vehicle speed. The higher the vehicle speed, the less help from that electric power steering that I need. In fact, let's go ahead and take a look at that power steering unit now. I'm going to put my bright light in here and also a laser. So behind that little pressure device for our fuel system, way down there where the flashlight is going back and forth, you see a black, like a black cap, then you see a large stamped aluminum casing. That is the electric power steering system. That is part of the rack and pinion. So right there where the laser is, that's the EPS on this particular Chevy Cruze. Now what we're going to do is, just for grins, let's see if this thing works with the key on, engine stop. Go ahead and turn the wheel and see if we see a PID change, and tell me, go ahead and shout out here to me in the front of the car, does it feel easy to turn or is it hard to turn? Hard to turn. It is hard to turn, so we're waiting till an engine run signal for it to work. But because it is electric, we wouldn't necessarily have to do that. We don't have to have the engine running. Just like a hybrid has a DC to DC converter, you don't have to have the engine running to get that 14.5 volts of charging voltage out of it, as long as the electric stuff is powered up. Let's go ahead and look at that steering angle sensor. I'm going to see if I can highlight that. Steering wheel angle, 158 degrees, and then we've got newton meters of torque. Let's go ahead and put it back on degrees. Turn the wheel again. We see it changing. We see that torque input right below it change as well. Let's go ahead and start it up now. Now see if the wheel is easy to turn, just like in butter. Nice and easy to turn. Easy. Not much steering input torque-wise. That's because we've got the assistance of the electric power steering doing the job for us. Now if we go down here and look at some other things, if you wondered, did I successfully program or calibrate my steering angle sensor? Now it's saying power steering control module center procedure. So just like centering the position mechanically on hydraulic power steering, you need to do that with electric power steering, and that PID tells us we've done that. And we go ahead and scroll down a bit. There's also calibration complete, learn status for the soft stops. So that's turning the wheel back and forth. And then talking about the worm gear and the worm gear counter, all kinds of PIDs. Get into deeper and deeper. Almost seems like we need an electric power steering class at this point, don't we? All right, let's see what we can do with the scanner regarding special functions, learns, and so forth. I'm going to go ahead and back out. It's just plain interesting, isn't it? There we go. We go up to reset configuration, reset functions, learning things, and we'll see what we can find. The steering angle sensor relearn actually might be in the stability control, which would probably be in the ABS. So what we can do here, we can do power steering stop soft resets. We can do power steering soft stops learn, a couple of features in the power steering module itself. So probably the steering angle sensor, since it has double duty, it works with stability controls, which is part of ABS on this vehicle. We would find the relearn procedure in that module. Obviously consult the service manual. It may be simpler than using a scan tool. Sometimes it's a simple matter of disconnecting the battery and cycling the key and things like that. So anyways, here's just a little teaser for you for maybe a video coming down the road on electric power steering as they get more and more mature and they show up in your shop. But one thing for sure, a couple of questions might just show up on your A4 test.